All right. Well, so welcome back, guys. You know the drill. We're gonna give you about a minute to get here, so we can enjoy the last show of 2021. Alrighty, I think we are ready. Hi, everyone, and welcome back to DSS Break. I'm here live every Thursday to talk about data science experiences and best practices with leading data professionals in a 15-minute break. I'm Anna Anderson, founder and CEO at Formulated by, the home of the Data Science Salon, and I'm streaming live from our HQ here at Formulated by, located in the heart of the Miami Design District. And today I'm really excited to welcome Pragya Nayak, a chief data scientist at Hitachi Vantara Federal. She has a PhD in computational sciences and informatics and over 22 years of experience in software development and data science in federal government. And she's a speaker, guest lecturer, community contributor. And today she will tell us a bit more about her story and best practices in the next 15 minutes. Welcome, Pragya. I'm really, really happy to have you here with us today. Why don't we jump in with you kind of telling us a little bit about your background and how you got it into this whole space?
Sure. Thank you. Thank you, Anna, for the warm welcome. And thank you, Data Science Alone, for this opportunity to share my story. So I did get started on my data science journey when I started looking for a topic for my PhD. My background was in computer science. Computers had always interested me, and I was looking for something which was more application oriented, and that's how it got started, and it's been a joyride ever since, working through various different types of data, and then getting a chance to I started working with a federal contractor, so getting exposed to the different types of data and different types of data challenges that the federal government has. So that's a unique tangent I could take in terms of a very specific data domain that I could focus on. And it's been an interesting journey, looking at different approaches, um, different unique trends and patterns in these in public sector, and how do we go about addressing them, and what is solvable, what is not solvable. So uh, it's it's c- it's a it's a continuous journey and a continuous learning journey for sure.
Yeah, no, it sounds like it. It's very interesting. It's very, yeah, like I feel like being part of, government has so many interesting initiatives. And maybe you could tell us a little bit about maybe some of the ones that you're involved with and the most ones that you're kind of excited about, or maybe our audience would find most interesting.
Sure. So there are various different types of data science challenges that we get a chance to work with. One of them is often in the space of records management. So there are all these different tools and techniques which the federal government agencies use as part of their day-to-day operations, and data is being collected. For example, even like something simple as like files are being generated as they're doing their day-to-day operations. They're sending emails to each other, so keeping track of those and then being able to uh, gather data around these data sets and then using it for their operational analytics and figuring out how much more space do I need, how much more storage do I need to buy so that I can continue my operations in this same performant manner, things like that. Second aspect is where they look at the different datas and try to understand um, the the patterns and trends in it, and then figuring out what else can we do with this data, not just this current data, but also being able to combine with other data which is out there, not just necessarily within my given agency, but also across the other agencies. What makes sense to uh, combine together and help me answer some of the questions which I could not answer before due to lack of data. One interesting work I had done was in the space of um, waste data from EPA. So taking a look at that and looking at where are these super sites where waste data is being accumulated, and then working with those the chemical engineers, analysts, and figuring out what is the chemical composition, which is more poisonous, and how do we do that.
Yeah,
Um,
that's cool. That's very interesting.
and coming up with visualization, so it's easily apparent and immediately obvious to you that oh, this is an area I should focus on, let's look deeper into it. So it's always been that type of thing where you start with looking at a broader level, and then you're like starting focusing and looking deeper and deeper. And in the process, I get a chance to work with these domain experts and understand their specific needs, and then mapping it to uh, a data science technique in the whole process.
Cool. That's really neat. And maybe since we're on this topic, maybe you could tell me a little bit about what your typical day looks like. It must be very different every day from what I can imagine. So, but maybe you could share a little bit of what that looks like for you as the chief data scientist there.
Sure. And isn't it for everybody? Like all our days are so uh, different. Like I always say that I start off with my TBD list, to be done list, and then if I get to the first two items, I'm lucky enough. But jokes aside, um, it is obviously centered around data and answering questions, making sure all the stakeholders are on the same page as we are making progress on a solution development, figuring out the priorities in terms of which of the specific data analysis that we are trying to accomplish, which is more high priority, what are the our roadblocks in getting to that solution space, and how do we overcome it in terms of both technology, people, and process. All the three come into factor. Um, Quite often we have the solution architecture in place. However, uh, manning those solution development, do we have the right resources in place? Do we need additional resources to be pulled in just because we want this done sooner, or it has increased in scope? And then one other aspect of my work is also looking for other opportunities that we can pursue, and then be able to uh, provide a solution and be accepted for that solution, and then start that work in the process. So different aspects of these type of tasks is what fills my day, and we just trudge along on that journey.
No, that's interesting. I mean, yeah, it sounds like you're never bored, that's for sure. So,
No, no. Can we make the day 48 hours?
I know we need more for everybody needs a little more time in a day. And where do you see kind of what value do you see in collaborating and being engaged in data science communities? Kind of what have you gotten out of that? I know that you're very involved in many different communities. Maybe you could talk a little bit about that.
Sure. Yes. So data science is a team sport for sure. That's not a cliche. That is a reality, a hard reality in our field. It is a team sport just because the field is evolving. There's always something new to learn. There's always something which somebody else knows better than you. There's always something that you haven't heard of before, and it's somebody has worked on it and you want to learn about it. And the best way to do that is via forums like yours and other similar communities, where you get a chance to quickly learn about some of these things, and and oftentimes they're not even get a chance to do a deep dive on some of these terms and concepts and technologies that you hear about. um, so in my space, we used to have a very active, thriving data science meetup that we had going on. So I'm based out of Northern Virginia, DC Metro. So we had a deep learning based meetup going on, which was very active, but due to the last 2 years we have taken the backseat. That is definitely something I'm looking forward to get revived in 2022, and look at different ways in which the virtual format can be leveraged for that purposes, and not completely lose that medium of team and community engagement.
Right.
So
Yeah, no, I think we're doing a lot of more hybrid things, right? So, yeah, no, that's really great. And I hope, even if you can't go back in person, you continue to do some virtual things for the meetup, for the community,
yes,
because I'm sure you know, they want to be engaged with. So, as all
definitely,
people do. So, and you
definitely.
just recently gave an overview of 5 concepts to increase the success rate of AI projects at our DSS event. And for those of you who didn't see that presentation, what are those 5 concepts about? Maybe you could talk a little bit about those for the audience.
Sure. Sure. So first of all, thank you for the opportunity to share that talk with all of you, and it was I had great fun preparing for it. So when we look at a data science project, it's often we always hear of these stories where a, a project kicked off and then, but eventually, for some reason or the other, it did not meet its end goals, and there are various reasons for that to happen. One is where there was not the adequate backbone for that data science project to be a success to begin with. The first factor is definitely data engineering, that you do not have a scalable manner in which your data is being collected, and you're getting access to newer data, you're getting access to the right data in the right format, and you're not just getting access to the data, but also the metadata which is there with that. And it
Right.
becomes more important when you're working with unstructured data, such as images, audio, text files, log files. Um, and in those cases, your metadata is absolutely more important,
Mhm.
equally important as the data, because that gives you a lot of insights into the data itself. Getting that in place. So, and how do you get all these things in place is via effective data ops mechanisms. Um, and Having a solid process by which you're getting the right data, access to the data to the right people, and then having that continuous communication among the different stakeholders of the data science project, defining the right problem. Uh, it should not just be a cool, uh, pr- cool thing to do. Rather, it should be the right thing to do, and data science is the solution that is helping you answer and address a specific problem. So, problem definition um, is extremely important. So those are some of the 5 things which I had highlighted on. There are a couple of others. Definitely encourage folks to check out the video and look forward to the feedback. And if you have other pillars you can think of as which will make your data science projects more successful.
Yeah, no, it's a really great presentation. We'll share a link for it after this the live session. And you also recommended applying design thinking principles for communication between business and data teams. Maybe you could talk a little bit what that actually looks like in
Sure.
practice.
Sure. Like as I said, data science is a team sport. It is made up of not just the data scientists, but also the domain experts, the business people, the stakeholders, the actual users of the whatever data product you are developing. And now, as you can imagine, each of them has their own different terminology, their own different stake in the whole solution. They're looking for different objectives out of it. And how do you have that shared language, that shared thinking, so that everybody is looking towards a common goal? That is best accomplished by design thinking, um, in terms of you're always looking at the usage of the product and how are you enabling that. Asking the right questions, posing the right questions, having that communication flow across all these different people who understand this in their own different language that they have, different terms that they have. For example, a business person may be looking at return on investment, but a technical person in the back end looking at the database is more concerned about which which particular column in my database table I should be looking at for this. So
Right.
getting that mapping is what is enabled by design thinking and the clear formulation of the objectives of a data product.
Yeah. No, that's a great explanation. Thank you so much, Pragya, for joining us today. It was great to have you. And this was our last DSS break for 2021. And we hope you have a wonderful Christmas and New Year's and other holidays that you celebrate. And we look forward to seeing everybody in 2022. And again, thanks, Pragya. I hope you also have a wonderful holiday.
Thank you, everyone. Thank you, Anna and Data Science Salon. Bye bye. Happy holidays.
Happy holidays.